Welcome back, everybody. This is part 2 of homework review for lesson 33, angle radian measure of angles. And so I hope you guys got a chance to watch part 1, and you guys were able to figure out that the angle measured in radians is really the ratio of the arc length over the radius. In part 2, we're going to take a look at that ratio and kind of adjust a little bit to find different things. So again, we'll write down the formula. Theta, the angle measure in radians, is equal to the arc length over the radius. And so here we do know what the angle measure is. We're told that the angle measure is 3 pi over 4 radians. Now, this is very important. You can't necessarily use the same ratio when you're dealing with degrees. It only kind of works with radians, because by definition for radians. So we're going to say in this case 3 pi over 4. So it really helps to have our formula written out for us. We are also told the radius of this circle, okay, is going to be 7. So that's going to be, that's r, and that's theta. So that's 7, and we're looking for s in this case. Then which of the following closest to arc length s? So we'll solve for s, and that's just going to mean that we're going to multiply both sides by 7. So we're going to get 21 pi divided by 4 is equal to the arc length. But if in terms of pi, that would be exact value, inches in this case, but we're now going to use a calculator to approximate this. So we're now going to take 21 pi, so 21 pi divided by 4. And we get 16.49, which approximates to about 16.5. So S is about 16.5 inches. And that'll be choice 2. So one way to adjust this formula is we're going to, instead of isolating theta, we can isolate the arc length, because sometimes we want to find the arc length. So the arc length is just going to be the product of our radian measure times the radius. So this will be a new formula we can look at. Although technically it's the same as the original formula, theta equals s over r. Arc length is equal to now the angle measured in radians times the radius. Okay, so now for our last question. In question number 5, and so here's the idea. We're trying to convert our angle measured in degrees to radians, and by looking at, in this case, pieces of the circle. So we see here, and this is very important, and we'll talk about this a little bit after this question as well too, some ways to be able to do conversions of angle measures from degrees to radians and backwards from radians to degrees. Okay, so here we'll see in this case, angle in degrees is 360. That's the whole circle, and total number of radians is 2 pi. So that we use as our guide, and therefore 180 degrees is half of a circle. Therefore, our radians is going to be 1/2 of 2 pi, which is equal to 1 pi. Now, in this case, the idea of 90 degrees is going to be 1/4 of our circle. Therefore, it's going to be 1/4 times 2 pi times 2 pi. Now let's type the word 2 pi. And in this case, we're going to get in here pi divided by 2. Okay? So if we wrote it here as it'd be pi over 2. Okay? And 6 degrees, well, since the whole circle is 360, 6 degrees is going to be 1/6 of the circle, which means that we're going to do 1/6 times 2 pi. And so 1/6 of 2 pi will give us, in this case, 2 pi over 6, or pi divided by 3. Okay, so again, we would have 2 pi over 6, which is equal to pi over 3. Our 30 degrees is again half of 1/6, because, you know, we see in this case, we saw that 60 is 1/6, so half of that is 1/12. Or you can just, 12, and you can just divide 360 by 30, get 12, therefore it's 1/12 of the whole circle. And so we're going to take 1/12 and multiply that by 2 pi times 2 pi. And we're going to get, in this case, 2 pi over 12, or pi divided by 6. Okay? And finally, 45 degrees. Well, 45 degrees in this situation, we'll see in this case that is really going to be 1/8 of the whole circle. 1/8 of the whole circle. And so here, 1/8 times 2 pi is equal to, well, pi over 4, because 2 over 8 saves 1/4, so pi over 4. Now these values, now I'll write them on the side, hopefully it'll be helpful to see. So we have pi over 2 here, so pi over 2, this is pi over 3, this is pi over 6, and this is pi over 4. Okay, but is there a way to be able to convert these angle measures into degree measures into radians? And so yes, there is. So here we go. We're going to have for ourselves a formula, write ourselves a kind of a rule in this case. In this case, converting degrees into radians. Okay? Okay, so here we go. Step 1. We multiply the degree measure by the fraction pi over 180. So I should get the pi symbol. Here's a pi symbol. Pi divided by 180 degrees. And I'll put the little degree symbol. I'll get rid of this here. And put a little degree symbol here. Okay. There you go. All right. So that's really what it is. Step 2 would just be, not really, it's just step 2, simplify the fraction. Okay. So that's what it comes down to. Okay. So really what we're doing in this case is we're just going to take our angle measure, line this up a little bit, all right? And so multiply degree measure by a fraction of pi over 180. And the reason is this: 2 pi represents the whole circle, 2 pi radians. 180 degrees represent 360 degrees represents a whole circle. So we simplify pi over 180 as the same value. So pi, because pi radians is equal to 1/2 a circle, and 180 degrees equals 1/2 of the circle. Therefore, pi over 180 is equal to 1. Therefore, it's equal to the same exact value, 1. Now, I know you're probably saying, pi is like 3.14, blah, 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 over 180, so that's not equal to 1. Well, as an angle measure representation, that's what it means. And so we're converting from one to another. So our example we can have in this case is that if we have 72 degrees, well, to convert 72 degrees into radians, we would do 72 over 1 times pi over 180. So we multiply this together. So now you get 72 over 180 degrees times pi. Now, the question is, okay, well, how many times can we simplify 72 and 180? Well, the biggest number that divides into both of them is going to be, I believe, 36. And so if you divide by 36, so divide by 36, and divide by 36, we're going to get, in this case, 2 pi, and this will be 5. So we convert the degree measure into radians, 2 pi over 5 radians. Okay? All right, so there you go. So this is a way to convert degrees into radians. Well, how do we convert radians to degrees? Okay, well, that's our next thing. So converting radian into degree measure. There's only two ways to do this though. Okay, method one. All right, method one in this situation, method one, step one, we would replace pi, so I gotta get that pi symbol there. Replace pi, oops, not that one, the symbol here, here you go, with 180 degrees. Our step two, simplify the fraction. So example would be in this case, let's say for example we had the pi over 12. Okay, 12 pi over 12 radians. Now to convert it to degree measure, we're going to replace pi with 180 because we said before pi radians is equal to 180 degrees. So we would get in this case 180 over 12. And 12 goes into 180, I believe, let's see now, once, 15 times. So it would be 15 degrees. Okay, so that's one method of simplifying, converting radians to degrees. Our second method in this case, method two, would be very similar to our converting degrees to radians. Step two, multiply the radian measure by 180 degrees, oops, over pi. Okay, so I just want to make this look like it's a degree measure here, so well, I know about that, so let's make sure it's specific. Okay, and then of course step two, simplify. Or estimate. Now I say simplify estimate because the fact that at this point, if you have pi radians, okay, it's so much easier to change into in this case, just simply to replace the pi with 180 degrees. If, however, you have an example where we have 2.3 radians, well, here it's not easy to replace pi here, so we would take 2.3 and multiply by 180 over pi. And so here we would have to write our calculator, all right? And so we take 2.3, and we're going to multiply by 180 and divide it by pi. And what I mean in this case is that we would then end up with approximation. So we would get 131.78 or about 131.8, so approximately 131.8 degrees. All right, so this is a way. So I would use the second method when we are dealing with a radian measure that did not have pi involved. All right, ladies and gentlemen, so hopefully this is helpful. I mean, we'll do a little more of this later on. I'll probably do a supplemental video of conversion if we don't have a chance to do more conversion problems, because I want to make sure we have practice with this. Thank you so much for watching. Hope this was helpful to you guys, and make sure to like the video if you found helpful. All right, ladies and gentlemen, take care and be safe.